Hello and welcome back to my video series on the concepts of the ACT Math section. This is continuing the intermediate concepts generally seen in the middle of the test or throughout. This one's going to be covering the sum of angles and scale, as in on like a blueprint or a map. These are two smaller, kind of random little topics that I couldn't quite fit into any of the other videos, so I finally just put them together into their own, probably shorter video. But as always, if you find it helpful, leave a like, subscribe if you want to know when I post more videos or help others find the channel, and comment with anything you like, any questions you might have, or any other videos you might want to see. But let's get right into it with the sum of angles. So what do you actually have to know for the ACT? If they give you the number of sides on a polygon, you have to know what the total sum of all the interior angles would be. They don't test this a lot, but they do test it every now and then. There's a few ways to know this, two primarily. The first is memorizing the formula, which is this right here. The sum of the angles, interior angles, would be n minus 2 in parentheses times 180 degrees. N here is the number of sides. Now, that is an option. It's a pretty simple formula, but if you haven't noticed by the number of videos here, there's a lot of stuff you're trying to memorize, especially on top of English and reading and science. So I generally don't recommend memorizing more stuff than you have to. So, we do have another option instead of memorizing this formula. So what can we do? Well, you should already have the triangle one memorized. So triangles, interior angles, will always add up to 180. I've got a separate video on angles that has all the stuff that you definitely want to memorize. This is one of them. Then, you should be able to figure out that a square or rectangle, well, that has 4 right angles, which are 90 degrees, so 90 times 4, that's 360. That's pretty easy. Then you just look at the difference. From 3 sides to 4 sides, adding one more side, we added another 180 degrees. And that's what that formula is doing. Just for every extra side past 3, just keep adding 180. And that's all you have to do. It's not hard at all. And that way you don't have to memorize anything. Just think of the triangle and a square. Now, generally, most of the times I've seen them ask this, it just goes up to a pretty small number of sides, like a pentagon or at most like an octagon. I think I might have seen 10 side ones, and that's pretty easy to do this. Where it can be a little bit harder to use this, and it might be nice to have the formula, is if they start asking for some crazy one, like 100 sides or 50-something sides. I've only ever seen them do it really once in all those tests that I've taken, so they probably won't, but I can't guarantee it. So memorize it if you would like. If you've already got everything else down, it's not a bad idea, but generally you're fine with just remembering this little trick. So now let's go to scale on a diagram or a blueprint. What do you have to know for this? You have to know how to convert from units in a blueprint, it's typically going to be length, to real-life units when you're given the scale conversion factor. So they will never ask you this and not give you that conversion factor. The trick is you have to actually read the word problem and realize this is a scale and that they gave you this. If you skim over it and don't see that conversion factor, there are going to be trap answers for just using regular conversions, which I'll give you an example of what we're talking about. Now these are typically going to be combined with area or perimeter problems. If you don't remember how to solve for these, I do have a video on that in the early concepts. So how do I solve these? Well, first, convert all of the values in the diagram or the blueprint into the real-life values using that given conversion factor. Do that first, and I'll go into why in the next couple slides. Or if you already saw my area and perimeter or volume videos, you already know the answer because it's the exact same thing. But I'll tell you again on these next slides. So after we've converted everything using that scale conversion factor that they give you, back up. Be careful. That conversion factor is often going to be different from normal conversion between units. So an example of that would be, you probably know, and you will need to know for the ACT, that 12 inches makes up 1 foot. So if they give you a map with things in inches and then ask for something in real life feet, you're not just going to divide by 12. That's normally what you do to go from the inches to feet. But we're talking about inches on a map to real life feet. They'll actually give you something like, okay, 1 inch on this map means 5 feet in real life. That's the conversion you're going to want to use. So there's gonna be some trap answers for if you use the 1 inch means 12, or sorry, 12 inches means 1 foot of normal conversion. So once you have everything converted, then you just solve the problem for that area, perimeter, or whatever it is they're asking for. So let's do a simple example here. A city planner draws out a blueprint for a rectangular fence around the park, seen below. Every inch on the blueprint represents 3 feet of fencing. That would be that scaling conversion factor that I was talking about. What's the total length of fencing? First thing we're going to do is convert all these, so these two terms, to real life feet of fencing. So we'll start with 6. Here, 6 inches. Every inch means 3 feet. So the 6 inches times 3 feet per inch. That's 18 feet. So this side would be 18 feet in real life. Do the same thing for the 15. We'll just multiply by the 3, that conversion factor here. You get 45. So really this is 18 feet, and this is 45 feet in real life. Now, note, I multiplied by 3, the conversion factor that they gave us. I didn't go by 12 or divide by 12. If I just skimmed through this and saw, oh, 6 inches, and they want things in feet looking at my answer choices, I might have just divided by 12, and I'd get the wrong answer. But now that I've got these converted, I just solve for the perimeter. So the 18 times 2, so 18 plus 18 plus 45 plus 45, the other side, gives me 126 feet. And that's my answer. So, as I've said before with these warnings a few times, there's going to be trap answers. So 42 feet is going to be a trap answer. If you didn't convert at all and just did the 15 plus 15 plus 6 plus 6, that's going to be one of the wrong answers. And they're also going to have 3.5 feet, which would be if you had just divided all these inches by 12, using 12 inches means 1 foot. Because I'm not converting a normal inch to a normal foot, I'm converting a diagram scaled inch to a real-life foot. Another note, I could technically convert at the end here. So instead of converting at the beginning, I could have converted at the end. But that can cause problems. And that's what I'm going to go into in my next problem example, is what happens if I do it at the beginning versus the end in the troublesome scenario. So let's do it correctly first, converting at the beginning with this example. Again, we've got a blueprint for a park, but this time they're asking for the area. That's going to be the key thing. If they're not just using length, but if they're asking for area or volume, that's where you really want to be careful to convert first. But if you just always do it, you don't have to worry about when to do it. So again, every inch means 3 feet. So let's convert first, just like before. So I'll just skim through it because the exact same numbers. I just multiplied each of these by 3, so that's 18 feet in real life, and this is 45 feet in real life. And then I'll just solve for the area. So 18 times 45, that's 810 square feet. And that's my answer. Not hard if I convert first. But what happens if I convert at the end? Let's solve this again, converting at the end. So this time, I'm just going to solve for the area with what they gave me first. So 6 times 15, 90 inches squared. Now, all my answer choices are in feet, and they're going to ask for it in real life feet. So now I would just convert that 90, right? So 90, that's the inches, and they told me that every inch is 3 feet, right? So just multiply by 3. That'll give me 270 square feet, right? Well, no. And why is that? This is not even close to what I got when I converted at the beginning. That's because we did this wrong. If we're gonna convert at the end here, the units I'm in are square inches. They're not inches anymore. So if I'm gonna convert now, I actually have to square my conversion factor. So instead of multiplying by 3, I have to multiply by 3 squared. So really, instead of 90 times 3, I needed to do 90 times 9. That would have given me that same 810 feet squared. They love to test this with their scale problems or just their regular area problems. Anything where they're going to make you convert the unit, they're often going to go to area and see if you remember to convert first, or if you really want to do it the hard way, square your conversion factor. Now, if this was volume instead of area, you would have to cube the conversion factor or raise it to 3 because you would have had something like inches cubed that you had to go and convert. So you can easily see how you can forget to do this or you can do it incorrectly. So if you just always convert first, you don't risk making any mistakes with that because there's always going to be a trap answer for if you do mess that up. So convert first and you'll be good every time. But that's going to do it for this video. Good luck, and I'll see you in the next one.